monomials, we are going to take a very similar approach to how we learn multiplying monomials, and we will talk about the major rules. Okay, so multiplying monomials, it was a lot of addition and multiplication. Dividing monomials is a lot of subtraction. So in my first example here, I have a to the fifth power over a to the third power. So if we were to write this in expanded form, we can write this as one big fraction. A to the fifth power is multiplying a by itself 5 times. So we have a times a times a times a times a all over a to the third. A times a times a. Okay? Once we have a fraction here, you guys can notice that we can do some canceling. So a cancels with a, just like that, leaving us with 2 a's in our numerator. So this is the same as saying a to the second power over 1, which we can obviously simplify as a to the second power. One way that you can kind of skip this process right away is you could subtract your numerator from, or subtract your denominator from your numerator. So it's the same as saying a to the fifth power minus the third power. That would get you to a to the second power. Okay, the second one works the exact same way. Let's start with the expanded form, and then we'll talk about the shortcut. So we have a to the third power in our numerator. So we have a times a times a, all over a to the fifth power. A times a times itself 5 times. Okay, from here, we can go ahead and cancel. Cancel, cancel. And this leaves me with, nothing left in my numerator, or just 1 over a times a, which is a squared, which that is just our simplified form. 1 over a squared. Okay? We can also write this with our shortcut. A to the third minus the fifth power, which you'll notice the shortcut here gives us a to the negative second power. A to the negative second power is the same thing as saying 1 over a squared. A negative exponent flips into the denominator and becomes positive. Okay? It doesn't really matter how you write your answer there. Okay, we are going to skip 3 and 4. We can talk about those together in class. Okay, let's look at the rules of dividing monomials. So we have the quotient of powers. We already talked about this. We can subtract, as long as our base is the same, we can subtract our denominator from our numerator. So this is the same as saying a to the m minus n power. Okay, we'll do the right side on these examples to switch it up a little bit. So we have 2a cubed over 4a to the fourth. Okay, so this is the same as saying 2. Wait. Okay, take it back a step. So let's divide our coefficients here. 2 divided by 4 is the same as saying 1/2. And then in our numerator, let's subtract our powers. So we have a to the 3 minus 2 power. Okay, this would give us 1 times a to the first power over 2, which could just simplify as a divided by 2. Okay, 0 exponent. Remember, anything raised to the 0 power is just 1. So if we're looking at number 4 here, we are raising 25 times x times y times z to the 0 power. So that all just cancels out and becomes 1. So this one becomes 1 to the 12th power. Don't need to overthink that one. All this just becomes 1. Okay? A negative exponent, as I was kind of explaining earlier, it becomes the reciprocal. So a to the negative first power flips into the denominator to give us 1 over a, which is just the reciprocal. Okay, so looking at number 6, we can just subtract these right off the bat. So we've got b to the 4th minus 10 power, which becomes b to the negative 6 power. We can write this as a positive exponent by taking the reciprocal. So our b to the negative 6 flips into our denominator, giving us 1 over b to the 6th power. All right. So those are our 3 rules for dividing monomials. We can go over the left half together in class. Make sure you guys are asking questions if you have them. So let's knock out these first 2 examples here, and then we'll leave the rest for class. So simplify the following, leaving no negative exponents, okay? So we don't want any negative exponents. That means that we will have to use our negative exponent rules, if possible. So for number 7, let's start by dividing our coefficients. Simplify those down right away. 6 times 12, or 6 divided by 12 gives us 1/2. So that's going to be our starting point. And then we've got x squared divided by x to the 9th. Remember, we can just subtract our exponents. We've got x squared, x to the 2nd minus 9th power. Okay, let's go ahead and simplify those. So that becomes 1/2 x to the negative 7th power. Okay, let's take the reciprocal of x to the negative 7th power to give us 1 over 2x to the positive 7th power. So just take the reciprocal of just the x to the negative 7th power. If it helps you, you can rewrite this as 2 separate terms here. So you can see that process. That's why you don't take the reciprocal of 1/2. Okay. With number 8 here, we have x to the 5th times y squared over x times y cubed. So let's use our quotient of powers to subtract our exponents right away. So we've got x to the 5th power minus 1. Remember, 1 is the assumed exponent on x there, times y times 2 minus, or to the 2nd minus 3rd power. Okay, go ahead and subtract. X, 5 minus 1 is 4. Y, 2 minus 3 to the negative 1st power. Okay, we don't want any negative exponents, so we will have to take the reciprocal of our y value, which gives us x to the 4th times 1 over y, which can be simplified as x to the 4th over y. Okay, so I hope seeing those 2 examples help a little bit as far as the process goes. We will save the whole second half for class. We probably won't get through all of them, but we can pick and choose a couple until you guys feel all right with the process. Okay, please take some time, copy these down. They are in the note outline as well. If you want to just go through there and copy them, we will go over them at the start of class. All right, thank you guys for watching.